In this video, we are going to learn about the relationship between the sine and cosine of complementary angles. The standard is MGSE 9 through 12 with GSRT 7. Explain and use the relationship between sine and cosine of complementary angles. First, what are complementary angles? The complementary angles are those whose sum is equal to 90 degrees. The basic example is 30 and 60 degrees. These two are called as complementary angles because 30 plus 60 is equal to 90. Similarly, if you have 80 degrees, 80 and 10, they are called as complementary angles because their total is 90 degrees. And also we can say that 80 degrees is the complement of 10 and 10 is the complement of 80. Okay, now let us see the relationship between the sine and cosine of such complementary angles. Okay, let us write the values of this. Sine 0 degrees is how much, sine 30 degrees is how much. Let us make use of a calculator and find its values. So the first thing I have here, sine 0 is equal to 0. You have sine 30 is how much? It is 0.5. Sine 45 is equal to 0.7071. Let me write it down here. Sine 0 degrees is a 0. Sine 30 is 0.5. Sine 45 is 0.7071. Sine 60 degrees is equal to 0.8660. 0.8660. We are rounding all this to the nearest 10,000th, that is 4 decimals. And lastly, sine 90, which is equal to 1. Okay, now cosine values. Let us look at cosine values. Cosine 0 degrees is equal to 1. Cosine 30 degrees is how much? 0.8660. Cosine 45 degrees is 0.7071. Cosine 60 is equal to 0.5 and cosine 90 is 0. Okay, let me write them down. Here first thing, cosine 0, you had 1. Cosine 30 degrees was 0.8660. Cosine 45 degrees is 0.7071. Cosine 60 degrees is 0.5 and cosine 90 is equal to 0. So we can see that the value of sine 0 is 0 and cosine 90 is also 0, and the value of sine 30 is 0.5, which is same as cosine 60, that is 0.5. So we are seeing that sine 30 degrees is same as cosine 60 degrees because sine 30 is 0.5, cosine 60 is also 0.5. Just now we observed that 30 degrees and 60 degrees are complementary angles. So now how are they related? Sine, the sine of an angle is same as the cosine of its complement. Whatever may be the angle here, take its complement and find its cosine. Let us look at this example also. See that sine, here I have sine 45 is 0.7071. Cosine 45 is also 0.7071 because 45 degrees is a complement of 45 degrees. The total makes 90 degrees. In the same way, sine 60 is same as cosine 30 because 60 and 30 are complementary angles. Alright, so what we observe here is sine of any angle is same as the cosine of its complement. For example, that is one more example I'll write. I have sine, let me say sine 20 degrees. The value of sine 20 degrees must be equal to the value of cosine. How much? 90 minus 20 is 70 degrees. Sine 20 degrees is same as cosine 70. Verify it using calculator. Your sine 20 degrees, sine 20 is equal to 0.3420. And what is cosine 70? Cosine 70 degrees is also equal to 0.3420. It is 0.3420. This also 0.3420. So sine of an angle is equal to the cosine of its complement. The same thing can be demonstrated by using a right triangle. Now here we have a right triangle ABC. Okay, in this right triangle ABC, the angle C is equal to 90 degrees, and so the side AB is the hypotenuse, and let us label their sides also. Opposite to this angle A, we have the side A. The measure of BC is equal to A, and now opposite to B, I write B here, and this is C. The other triangle also, just it's a copy we have here. I'll write the same letters A, B and C. Alright, now let me find what is sine A. What is the value of sine A here? Sine A is equal to, like you know, first I have to label its hypotenuse, adjacent and opposite side. So for this angle A, now you already know that this is the hypotenuse. The longest side, or the side opposite to 90 degrees in a right triangle, is called as your hypotenuse. Our reference angle is A. You are dealing with this angle A. So for this angle A, one side is H, that's gone. So the other side has to be the adjacent, and the remaining side is the opposite side. Now we are looking for sine A. We know that sine is opposite side over hypotenuse, that is SOH. So sine A equal to opposite over hypotenuse, which is A over C. Okay, now we will move to the other triangle. In this triangle, like I said, it is just the same triangle. I copied it in order to see the relationship between the sine and cosine of the complementary angles. So now, in using this second triangle, I am going to find the value of cosine B. Okay, now the reference angle here is the angle B. In the first triangle, my reference angle was A. Now the angle is B. Even though the angle B you are taking into consideration, still this C is the hypotenuse, but adjacent side is going to be this one. BC is the adjacent because angle B you have here, one side is the H and the other is adjacent side. Now the remaining one, the third one, is the opposite. Now how do you find the cosine B? We know that cosine is what? That adjacent over hypotenuse. So cosine of this angle B equal to the adjacent side is A over hypotenuse, which is C. Okay, now what do you observe in this? We are saying that sine of this angle A equal to A over C, that A over C, and cosine of this angle B is also A over C, right? So I can write it as sine of that angle A is equal to cosine of angle B. So in this triangle, sine A, if you take, it is A over C, but cosine B is also A over C. Those two values are equal. Now what is the reason for those two ratios to be equal here? Because this angle A and angle B are related. Do you know what is the relationship between them? Let us see. In this triangle ABC, or for that matter in any triangle, what is the sum of the three angles? Angle A plus angle B plus angle C is equal to 180 degrees. The sum of three angles in a triangle is 180. Now in this you already know that the measure of angle C is equal to 90 degrees. So let me write down angle A plus angle B plus angle C is equal to 90 degrees. I substituted 90 degrees for C because I know that it is a right angle. And on the right hand side we have 180, the sum of three angles in a triangle. Now what next? Let me move this 90 degrees onto the right hand side so that I can subtract it from 180 degrees, and that gives me, bring down this angle A plus bring down that angle B. 90 and 90 got cancelled on the left hand side. Here 180 minus 90 gives you 90 degrees. That is the sum of those two angles, angle A plus angle B, is equal to 90 degrees. That is, A and B are what? They are the complementary angles. Because A and B are the complementary angles, the sine of this angle A is equal to cosine of angle B. From this you can also write angle B, the measure of angle B will be equal to 90 minus A. That is, if you remove A from 90, we get B. That is, sine A is the same as cosine 90 minus A. You can represent it this way also. For example, if A is equal to, let me take 20 degrees, alright, so sine 20 degrees is the same as its complement, which is cosine 90 minus 20, or we can say sine 20 degrees equal to cosine 70 degrees. Now let us solve one problem. Find the value of x. Given sine x is equal to cosine 50 degrees. Okay, given that sine x is equal to cosine 50, what is the value of x? X is equal to how much? How do you do this problem? Now we know that if sine A is equal to cosine B, this A and B are complementary angles. That is, the measure of angle A plus the measure of angle B, their sum, the total is going to be 90 degrees when you add them. So same thing is applied here. They gave us sine x, which is equal to cosine 50. Therefore I can write x plus 50 is equal to 90 degrees. They are complementary angles. X plus 50 is equal to 90. So from this, solve for x by taking away 50 degrees on both sides. Subtract 50. So you are left with x is equal to 40 degrees. That is your answer. So whenever you have something like this, sine x is equal to cosine 50, just go ahead and add those two angles and equate it to 90 degrees, because they are the complementary angles. Their total has to be 90 degrees. Now you please try these two problems. One is here. Let me take cosine x is equal to sine 56 degrees. Find the value of x. X equal to how much? And the second problem is sine x is equal to cosine 34 degrees. In both the cases, find the value of x. Okay, please try. Thank you.